In this video lecture, we're going to learn about this reaction in which a metal reacts with an acid and it ends up producing a salt, and it also produces hydrogen gas. So if you're in a lab and you do this reaction, you pick a metal and you put it in an aqueous solution of an acid. What you would immediately see is that the metal would start to dissolve, and you would notice bubbles of hydrogen gas being formed. So as soon as you put a metal in an acid, you're going to see bubbles of hydrogen gas. These bubbles would be very noticeable, and this piece of metal would slowly dissolve in the acid. So over time, this piece of metal is going to dissolve in the acid. It's going to basically, all the metal would end up forming this salt, as long as the acid is in excess. So the salt would be produced, and you would notice bubbles of hydrogen gas being formed. Now, not all the metals react in exactly the same way. Some reactions are very fast, they would be very vigorous, and some reactions would be very slow, so you would see very slight bubbles. So it depends on the reactivity of the metal. Now, I've written the reactivity series where potassium group 1 metals are very, very reactive, so their reactions are going to be very explosive. They're going to have very fast and vigorous reaction. Then group 2 metals the reactions would slow down, the reactivity decreases. And as you move down the group, the reactivity decreases further. So these top elements, from potassium to calcium, they're going to have very fast and vigorous reactions. So their reactions would be noticeably fast. They would be explosive, vigorous, explosive reactions. So reacting acids with these metals, that's not going to be very safe in the laboratory. Then you have the following metals from magnesium to tin. They have moderate reactions, which means that they're not very fast, not very slow. Their reactions are moderate. These metals would react in very good time, but they're not going to be very explosive reactions. So you can use these metals if you're doing this reaction in your school laboratory. You can use these metals and react them with acids, and they would be very safe reactions. So remember this: if you're asked to perform this reaction in the laboratory, then you can use these metals. One word that you can, mnemonic that you can remember, is MAZET, which stands for magnesium, aluminium, zinc, iron, and tin. So always remember these MAZET metals. They have moderate reactions, and you can safely perform these reactions in the school laboratory. Now, as you move down the reactivity series, the reactivity decreases further. Lead is very unreactive, but it reacts only at either the temperature has to be high, so it only reacts at high temperature, or the acid is very concentrated. So if the acid is very concentrated or the temperature is very high, only then would lead react. So lead is going to have no reactions with dilute acids at room temperature, or it's going to have very slow reactions. But if the temperature is high enough or the concentration of the acid is high enough, then this reaction would be feasible in the laboratory. The metals below hydrogen, their reactivity decreases further. So as you move down the group, the reactivity decreases further and further. So the reaction would become slower and slower. The reactions would take days and years for the reactions to occur. For example, to dissolve copper in an acid, the acid needs to be very, very concentrated, and the reaction is going to be very, very slow. And as you move further down the reactivity series, for example, gold would hardly react with an acid. Its reactivity is almost zero. Platinum is also, it's hardly going to react with an acid. It's going to take thousands of years for some platinum, just a very tiny bit, to actually react with an acid. So almost no reactions occur for these metals below hydrogen. So for these metals, almost no reaction occurs. So you must relate this with the reactivity series of the metals. The more reactive ones have vigorous and explosive reactions. These MAZET metals have moderate reactions. Remember MAZET, you must, because this comes into play later on. So remember, metals have moderate reactions and they can be safely performed in the school laboratory. Lead only reacts at high temperatures or if the acid is very concentrated. And the ones below hydrogen have almost no reactions. So the reactions are almost non-existent. So we're now going to figure out how to write an equation with the formulas of this reaction. So I'm going to pick any metal. Let's pick sodium, which is one of the most reactive metals. So it's going to be a vigorous explosive reaction. And I'm going to react it with hydrochloric acid. So HCl would be my acid. And remember, a salt would be produced and hydrogen gas would be produced. Remember, hydrogen gas would always be produced. So you write down hydrogen as it is before doing anything. And recall how we actually ended up forming salts. I did video lectures on the formation of salt, how to figure out the formula for salt. So if you have an acid, now this metal would neutralize this acid. What that basically means is that it's going to get rid of this hydrogen. It's going to neutralize that acid. An acid is only an acid if it has H+1 ions. So if it gets neutralized, you get rid of the H+1 ions. So if this HCl you get rid of the H+1 ion, it would no longer be able to act as an acid. So what you're going to do is you're going to replace this H over here, with the sodium ion coming from sodium metal. So if I do that, you will get NaCl. Na is +1, Cl is -1, so the formula is going to be NaCl. So this is the salt that would be produced. So remember, I'm going to write this again. A salt is produced if you neutralize an acid. Get rid of the H+1. So get rid of H+1 ions in acid. And you replace those H+1 with any other positive ion, which in this case would be coming from the metal. The last thing that we need to do is we need to balance this equation. So I've written this equation again, and you would notice the only thing that's unbalanced right now are the hydrogens. There are two hydrogens over here. There's only one hydrogen on the left hand side, so let's make it 2 molecules of HCl. And now Cl are 2, so there should be 2 molecules of NaCl. Now sodium is 2, so there should be 2 sodium metal atoms. Now this equation is perfectly balanced. So don't forget to balance this equation, because whenever you write an equation, it is understandable that it has to be balanced. Let's do another reaction, and this time again I'm going to pick sodium metal, and I'm going to pick phosphoric acid. I'm going to react it with phosphoric acid, which is H3PO4. And again, it's a metal plus acid reaction, so it's going to produce a salt plus it's going to produce hydrogen gas. So the only thing I need to figure out is the formula of this salt. So get rid of the H and replace it with the other positive ion, which is going to come from sodium. So instead of this H, I'm going to write sodium in its place. I'm going to neutralize this acid. So if I do that, I'll get rid of the 3 hydrogen ions, replace it with sodium ions, and I'll have PO4. Phosphate, remember, is a polyatomic ion. It has a charge of 3-, so I need to figure out the formula of the salt now. I've gotten rid of the 3 hydrogen ions that were in phosphoric acid, replace it with a sodium ion. And if I use the crisscross method, that method is going to give me, if I use the crisscross method, Na would be 3 and PO4 would be 1. So I've used the crisscross method to figure out the formula of my salt, which is going to be Na3PO4, or sodium phosphate. So I'm going to rewrite this reaction now, and I'm going to try and balance this as well. So it's sodium plus H3PO4, giving me sodium phosphate, which is Na3PO4, plus hydrogen gas. Remember, PO4 was 1, so you don't really need to mention 1. It's very obvious that PO4 is 1, even if you don't write 1. So I need to balance this equation. Now I'm going to try and balance this equation. So there are 3 sodiums over here. Let's balance hydrogen first. There would be 2 molecules of hydrogen. That would make it 6 hydrogen. There would be 3 molecules of H2. That would make it 6 hydrogen. So phosphoric acid, hydrogen is balanced now. PO4 is 2, so there should be 2 molecules of Na3PO4. And sodium is, there's 6 sodiums on this side, so on the left hand side there should be 6 sodiums. Now it's a balanced equation. So it's a metal reacting with an acid and it's producing a salt and it's giving off hydrogen gas. Now I'm going to do a number of examples for the same reaction, which is metal plus acid produces salt plus hydrogen. So I've picked a number of metals and a number of different acids. I'm going to make an equation using the same method that we discussed previously. So let's look at the first one, where aluminium, which is a group 3 metal, is reacting with hydrochloric acid, HCl. And again, it's going to produce, it's a metal plus acid reaction, so it would produce salt plus hydrogen gas. So hydrogen gas would be produced. You write hydrogen gas as it is, and remember how a salt was produced. You neutralize the acid, you get rid of the hydrogen ion and replace it with the other positive ion, which is going to be aluminium ion in this case. So instead of this hydrogen, you're going to neutralize this acid, get rid of this H plus one, replace it with the other positive ion, which in this case is aluminium. So it's going to be aluminium, which is 3 plus, and Cl, which is minus 1. So since aluminium is 3 plus, Cl is minus 1, we can use the crisscross method, and the formula of the salt is going to be, it's going to be AlCl3. So using the crisscross method, this 3 comes over here, 1 comes over here, so there's going to be 1 aluminium and there are going to be 3 chlorine ions in the formula. So it's AlCl3, and we can rub off the charges because the overall charge is going to be 0. So the formula of the salt in this case is AlCl3. The next thing that we need to do is we need to balance this equation. So if you look over here, there are 3 chlorines, so there should be 3 chlorines on the other side as well. So this should be, there should be 3 molecules of HCl. But if I do that, what that would do is there would be 3 hydrogens now in HCl. There would be 3 molecules of HCl. So that would mean I have 3 hydrogen atoms. So there should be 3 hydrogen atoms over here as well. But I just have an H2 molecule, so I can't make it into 3. I can't convert this into 3. So what I would do is I would have 3 molecules of hydrogen. What this would do is that would make a total of 6 hydrogens. So over here I can have 6 hydrogen. If I remove the 3, if I get rid of the 3, so I remove the 3, and if I use 6 HCl, now my hydrogens are balanced. There are 6 hydrogens over here and there are 6 hydrogens over here as well. But my chlorine, which I balanced earlier, is now unbalanced. There are 6 chlorines over here and there are 3 chlorines in this molecule. So this should be, there should be 2 molecules of AlCl3, 2 moles of AlCl3. That would make it 6 chlorines. And since aluminium is 2, there should be 2 aluminiums. Now this is a balanced equation of aluminium reacting with HCl, and it produces AlCl3 and 3 molecules of hydrogen gas. The next reaction is also a similar reaction, metal, potassium metal, which is a group 1 metal, reacting with sulfuric acid, which is H2SO4, and again it's going to produce a salt and it's going to produce hydrogen gas. So we will write down hydrogen gas as it is, because it's always going to be produced when a metal reacts with an acid. And I need to figure out what the salt is. Again, remember, a salt is produced when an acid is neutralized. Get rid of the H plus ions in the acid and replace it with the other positive ion, which is K, potassium ions coming from potassium. So put those ions over here instead of H plus 1. That way the acid would be neutralized. So I'm going to put K instead of H. So it's going to be KSO4. Now SO4 has a charge of 2 minus. It's a polyatomic ion, sulfate ion. And potassium has a charge of 1 plus. So the formula using the crisscross method, get this 2 over here and this 1 over here. So the formula is going to be K2. And SO4 would just be 1. So you don't write 1. Get rid of the charges because the overall charge, the positive and negative charges would cancel out. So the formula of the salt is going to be potassium sulfate K2SO4. And the last thing I need to do is I need to balance this equation. Everything is balanced. There are 2 hydrogens over here, there are 2 hydrogens over here. There's 1 sulfur, 4 oxygens, 1 sulfur, 4 oxygens. Everything is balanced except for K. There are 2 potassiums over here. So there should be 2 potassiums at the other side as well. Now this is a balanced reaction between potassium and sulfuric acid, and it's producing potassium sulfate and hydrogen gas. Let's now do this third reaction with magnesium metal reacting with nitric acid, which is HNO3. So it's again a metal plus acid reaction. It's going to produce salt plus hydrogen gas. Write down hydrogen gas as before. And we're going to figure out what the salt is going to be. We need to neutralize this acid to get the salt. Get rid of the H plus 1 in the acid and replace it with the other positive ion, which is magnesium. Now remember, magnesium is from group 2. So magnesium ions will have a charge of 2 plus. So if I put magnesium instead of H over here, so it's going to be Mg NO3, got rid of the H. Now NO3 is a polyatomic ion, nitrate ion, it's 1 minus, Mg is 2 plus. So the formula using the crisscross method is going to be Mg would be 1 and NO3 would be, there would be 2 NO3s. Put a bracket around it to show clearly that the entire NO3 is 2. And remove the charges, the positive and negative charges would cancel out, so the overall charge is going to be 0. So these are your formulas of the salt formed and hydrogen gas formed. And the last thing is we need to balance this equation. So magnesium is already balanced. There are 2 NO3s over here, so there should be 2 molecules of HNO3 over here. Hydrogens are balanced as well. In 2 molecules there are going to be 2 hydrogens. In 1 molecule there's 2 hydrogens. So the hydrogen is also balanced. So magnesium plus nitric acid produces magnesium nitrate plus hydrogen gas. We are going to do another reaction of metal plus acid. This time I have barium metal and I have phosphoric acid. And again the products are going to be salt plus hydrogen gas. So hydrogen gas, I'm writing down hydrogen gas, H2 would be produced. Plus the salt, again I told you, and you need to neutralize this acid, get rid of the hydrogen ions in the acid and replace it with the other positive ion which would be coming from barium. Remember barium is in group 2, so group 2 barium would have a charge of 2 plus. So the formula of the salt is going to be barium would replace the hydrogen ions, so it's going to be Ba and PO4. PO4 phosphate is 3 minus, barium is in group 2, it's 2 plus. Using the crisscross method, get this 3 over here and this 2 over here. So the formula of the salt is going to be barium, there would be 3 barium ions and there would be 2 phosphate ions. So this is the formula of barium phosphate, Ba2 and PO4 would be 3. Ba3 and PO4 would be 2. Get rid of the charges, the overall charge is going to be 0. So get rid of the charges. And now you need to balance this equation. So there are 3 bariums on the right hand side. So I need 3 bariums on the left hand side. The 2 PO4s on the right hand side. So there should be 2 PO4s on the left hand side as well. Now there's 6 hydrogens in total. So there should be 3 molecules of hydrogen. Now the equation is completely balanced. So this is your reaction. Barium reacting with phosphoric acid produces barium phosphate and gives off hydrogen gas.